Somewhere beyond the edge of everything we've ever seen lies a question so immense it stretches our very imagination. Just how big is the universe? Not in theory, but in reality. Is it endless? Does it loop around on itself? Or is there some kind of cosmic wall waiting out there in the darkness beyond which nothing exists? We gaze up at the stars and feel small, but what if we told you? We're even smaller than we think. The universe isn't just big. It's bigger than big can describe. And the deeper we look, the stranger it becomes. Entire galaxies vanish. Behind horizons we'll never reach. Space stretches, time bends, and distances become so vast they're almost meaningless. In this video, we'll explore how we measure the unimaginable size of the universe, the mind-bending concept of cosmic inflation, the haunting idea of an edge, or lack of one, and what the true scale of existence might say about our place. And in it all, the universe, as far as we know, began around 13.8 billion years ago with the Big Bang, an explosion not of matter into space, but of space itself expanding outward in all directions. In those first moments, everything we see today, galaxies, stars, planets, and even us, was compressed into a single unimaginably dense point. As space expanded, it carried matter with it, shaping the vast cosmic web we now observe. But here's where it gets fascinating. No matter where we look, in any direction, we see galaxies rushing away from us. It's as if we're at the center of the universe. Except so is everyone else. This observation led to one of the most profound discoveries in cosmology. The universe is not only expanding, it's expanding faster and faster. We measure these distant objects through redshift. How? Their light stretches as space itself grows. But when astronomers pushed the limits of their instruments, they began to detect something truly bizarre: the cosmic microwave background, a faint glow of radiation coming from every direction. It's the leftover heat from the Big Bang, frozen in time. This background radiation confirmed the universe's explosive birth and gave us our first real clue about its size. But even more puzzling was what followed, a period of cosmic inflation, where the universe expanded faster than the speed of light itself. In mere fractions of a second, it ballooned beyond comprehension. These discoveries weren't just groundbreaking. They cracked open a new chapter in our understanding, revealing a cosmos far bigger and far weirder than anyone had dared imagine. To understand how big the universe truly is, we need to grasp how scientists measure something so vast, so unreachably distant, that even light, the fastest thing we know, takes billions of years to cross it. It starts with light itself. When we observe distant galaxies, we're not just seeing them as they are. We're seeing them as they were, millions or billions of years ago. Their light has traveled across time to reach us, and the farther away a galaxy is, the more its light has stretched, redshifted, because the space between us and it has expanded. Think of a balloon with tiny dots drawn on its surface. As you blow up the balloon, the dots move away from each other. That's how galaxies move, not because they're flying through space, but because space itself is growing. And that expansion isn't slowing down, it's speeding up. Thanks to telescopes like Hubble and the James Webb Space Telescope, astronomers have detected galaxies over 13 billion light-years away. But here's the twist. Because the universe has been expanding all that time, those galaxies are now much farther than 13 billion light-years. In fact, the edge of the observable universe is about 46.5 billion light-years in every direction. We call it the observable universe because it's the limit of what we can currently detect. Beyond that, space likely continues, possibly forever. Or maybe it curves back on itself like the surface of a sphere. We don't know. But with tools like neutrino detectors buried deep underground and gravitational wave observatories like LIGO, We're now sensing ripples and particles from the most ancient and violent events, black hole mergers, supernovae, even echoes from the Big Bang itself. What we're uncovering is astonishing. The structure of the universe, the way galaxies clump together into filaments with vast voids in between, suggests an architecture far more massive than we can comprehend. And the fact that expansion is accelerating. That hints at something even stranger: dark energy, an invisible force pushing the universe apart faster and faster. The more we learn, the clearer it becomes. We're just beginning to scratch the surface of something unimaginably immense. Here's where things get truly mind-bending. When we talk about the size of the universe, we're also talking about time, because the farther we look, the further back in time we're seeing. That galaxy, 13 billion light-years away, its light has been traveling to us since the universe was just a few 100 million years old. So even if something spectacular happened there, like a star exploding in a supernova or an entire galaxy colliding, it might have occurred eons ago. We're only seeing it now because the light is just arriving, and the reverse is also true. Things we observe now might have already changed or vanished entirely, and we'd have no way of knowing yet. That's the cosmic delay we live with. It's possible that somewhere, right now, a massive star has exploded in a stunning supernova, lighting up its entire galaxy. But we won't see that burst of light for tens of thousands or even millions of years, depending on its distance from us. Yet, when these events do reach us, the spectacle can be unforgettable. A nearby supernova, for example, could appear as bright as the full moon in our sky, visible even during daylight. It could cast shadows at night, dominate the sky for weeks, and leave behind glowing remnants for generations. These are not just astronomical events. They're time-traveling messengers from across the cosmos, hinting at the universe's scale in the most dramatic way possible. And they remind us that what we see is only a snapshot of what was, a whisper from a universe that never stops changing. Imagine stepping outside one quiet evening, expecting the usual canopy of stars, and instead being greeted by a new light in the sky. It's not a planet or a plane. It's brighter than Venus, brighter even than the full moon. It casts a faint shadow across the ground. It glows steadily, silently, for weeks. That light, it's the final breath of a massive star ending its life in a colossal supernova explosion. If such an event were to happen in our own galactic neighborhood, say within a few hundred light-years, we wouldn't just read about it in science journals. We'd see it with our own eyes. The explosion would unfold across the night sky like a slow-motion cosmic firework. Depending on the star's mass and distance, the light could last for days, weeks, even months. Bright enough to be visible in daylight, impossible to miss even in a city sky drowned by light pollution. For astronomers, it would be the chance of a lifetime, a front-row seat to the death of a star. For the rest of us, it would be a shared human moment, like an eclipse times 1,000. We'd pause, look up, and wonder about life, death, the universe, and our place in it all. It wouldn't just be a sight to behold. It would be a reminder that we're part of a living, evolving cosmos, a universe that still holds mysteries powerful enough to leave us breathless. A supernova isn't just a spectacle. It's a scientific treasure trove. When a massive star dies, it does more than light up the sky. It forges the very elements that make life and everything around us possible. Inside its collapsing core, temperatures soar into the billions of degrees. In those final violent moments, the star becomes a cosmic forge, producing heavy elements like gold, platinum, and uranium, elements that can't be formed through normal stellar fusion. They're blasted into space, scattered across the galaxy, and over millions of years they become part of new stars, new planets, and eventually, us. It's cosmic recycling on a grand, elegant scale. The iron in our blood, the calcium in our bones, the oxygen we breathe, They all came from ancient stars that lived and died long before our sun was born. Every atom in our bodies was once part of a stellar furnace. Without supernovae, the universe would be a barren expanse of hydrogen and helium. With them, it becomes a place rich with diversity, complexity, and the potential for life. That's why astronomers watch stars like Antares or VY Canis Majoris so closely. These giants are ticking clocks, each one a potential source of the next. Great explosion. The more we learn about them, the more we understand the history written in the atoms of our own bodies. Watching a star die is, in a way, watching the universe continue its grand story, a story that includes all of us. As dramatic as a nearby supernova might appear, there's no need to worry. It wouldn't pose any danger to Earth. For a supernova to truly threaten life here, it would have to occur within just a few dozen light years. Fortunately, all the stars we're currently watching, like Betelgeuse, Antares, or VY Canis Majoris, are safely hundreds of light years away. That means we'll get the show without the shock. At most, we might experience some fascinating but harmless side effects. The explosion's energy could slightly increase the ionization in our upper atmosphere, possibly triggering more vibrant auroras, those shimmering curtains of light near the poles. It's not a hazard, just an added layer of beauty. What's even more impressive is that our scientific community is ready. Deep underground, neutrino detectors are constantly scanning for ghost-like particles that escape from a supernova's core before its light does. These elusive messengers can give us a precious early warning, maybe hours or even days before the visible light reaches us. When that happens, observatories around the world will lock onto the source, and humanity will be united in witnessing a rare and beautiful cosmic event. Together, safely. We're witnessing the final breath of a giant. A farewell, millions of years in the making. The light from that distant star has traveled across the darkness of space for centuries, passing galaxies, nebulae, and cosmic dust, just to reach our eyes in this fleeting moment. And when we look up and see it shimmer, we're not just watching a star die. We're witnessing a message from the deep past, a glowing echo of something long gone. It reminds us how small we are, and yet how incredibly lucky. Lucky to exist in a universe where stars live, die, and in doing so, create the building blocks of life. Lucky to have the tools and the curiosity to notice these fleeting cosmic events. Lucky to share this moment, this beautiful goodbye, with every other pair of eyes pointed skyward. When you next step outside and gaze at the stars, think about this. One of them may already be gone. Its final light is still on its way. Somewhere in the darkness, something ancient is trying to say goodbye. So keep looking up. The universe is full of secrets still waiting to be discovered. Silent explosions, distant signals, and stories written in starlight. All we have to do is keep watching and keep wondering. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. There's an entire universe out there, and together, we'll keep exploring it, one